This is a lecture on dividing decimals. I've set these division problems up using this symbol. There are several other ways I could set it up. So we're going to look at one of those. And what's happening here is 3 6/10 is divided by 9 100ths. Now when I look at that as a mathematician, we do not like decimals and division bars mixed together, so I want to get rid of those if possible. So how would I do that? Well, I'm going to multiply by 1. I can multiply anything by 1 in which I choose, and the problem would stay the same. But my 1 is not going to look like 1 over 1. It's really going to look like 100 over 100. And why might I pick 100? Well, when I take 100 times 3.6, the result of that is going to move my decimal place 2 places. So 3 6/10 is really going to become 360. Now how does that work? Well, if you recall our place values, here's my decimal, my tenths, my hundredths, and my thousandths are to the right, to the left, 1/10, hundreds, and so forth. Well, when I multiply by 10, it looks like I'm shifting 1 place for every 10 in which I multiply. Well, in 100 there are 2 10s. So if I shift my decimal place 2 points, 3.6 is going to get bigger and turn into 360. Likewise, 9 100ths times 100 is going to be 9. So I'm just going to convert this problem. I'm going to multiply each of these by 100 to shift my decimal. So I'm really going to have 9 divided by 360. And I know that 40 times 9 is 360, so 40 therefore is my answer. Let's try the same problem here again. I have 3/10, and I'm dividing 3/10 by 6 100ths. So I want to move my decimal 2 places, or in other words, I want to multiply by 100. If I want to keep my fraction equivalent, I must multiply by 100 in the numerator as well, or in other words, multiplying by 100 over 100, which is 1. Multiplying by 100 will move my decimal point 2 places, and this 3/10 turns into 30. 6 100ths times 100, 6 100ths times 100, if you recall, would just turn into a 6. So converting this decimal problem into something equivalent but much easier to perform would be 30 divided by 6, and the result of that is 5. Now if I want to think of this in terms of money, this 6 100ths is pennies, and the 3/10 represent dimes. The 3/10 represent dimes, so I have 3 dimes. Let's write that down. I have 3 dimes, and I want to know how many piles of 6 pennies can I make? How many piles of 6 pennies can I make? Well, if I have 3 dimes, that means I have 30 cents, and I'm going to divide that 30 cents into 6 piles. Therefore, I get 5 piles total. Let's try another problem. If you notice this one, the 7 is okay. So I'm not actually going to move my decimal. Let's look at what happens when I just do my scaffolding division like we learned earlier. I want to know, first of all, how many 7s are in 44. I'm leaving off the 10th because I'm not really sure. I'm just going to take these 2 digits themselves. That's 44. 7 goes into 44 6 times. Notice where I put the 6. It's above the 44 because those are the 2 digits I used. Multiply. I've used 42 of the 44 I have 2 1/10 remaining. And now I ask myself, how many 7s are in 2 1/10? Or how many 7s are in 21? There are 3 7s in 21, and my decimal point sits here because this 21 is looking at 2 1/10, which is really 20/10 and 1/10, which is 21/10. Notice I'm in my tenths position. And what kind of happens here is this decimal just goes straight up as long as I've aligned my numbers correctly. Let's try another one. This kind of has two problems here. The first is I don't like my decimal in this position. I must get rid of it so that my divisor is a whole number, something without a decimal. So in order to do that, I'm going to multiply everything in here by 10. So my problem now becomes 3 divided by 634 and 2/10. So use my scaffolding division. I see 634. Well, I know that there are 200 3s in 600. 3 times 200 is 600. I've used 600 of those pieces. I have 34 and 2/10 remaining. Well, in the 34, I see that I have at least 10, which would amount for 30 of those pieces. I still have 4 and 2/10 remaining. Well, in the 4, I know there's at least one group of 3, and I have 1 and 2/10 remaining. So when I look at 1 and 2/10, I ask myself, 1 and 2/10 is really 10/10 and 2/10, or 12/10. How many 3s are in 12/10? Well, how many 3s are in 12? There are 4. There are 4 tenths because I'm in tenths mode. Notice what happened. My decimal point just goes straight up, and that's where it lands. So on to the left of the decimal, I have 211. And on the right of the decimal, I have 4, or 4/10.